Hello, my name is Stratis Rallis and I am a grade 11 student from Athens College in Greece. During the summer break, I designed AI Medical Diagnosis, an algorithm that helps doctors make accurate diagnoses in order to combat the rising issue of misdiagnosis. The main problem I tried to solve is of course misdiagnosis, which is mainly caused by cognitive error on the part of the doctor due to the commonality of some symptoms which are also correlated with severe diseases. The main types of misdiagnosis are the following. The failed diagnosis, which occurs when the patient's disease is completely ignored, meaning they receive no treatment. The late diagnosis, which happens when a patient's disease is not diagnosed promptly, resulting in delayed therapy, increased costs for treatment, and a negative impact on their recovery. And the incorrect diagnosis, which happens when a patient is diagnosed with a disease or damage that is not truly present. This delays adequate treatment and may result in unneeded, potentially harmful treatment. Misdiagnosis can lead to permanent disability and even death of the patient because of wrong or no treatment. It is considered to be the third leading cause of death in the US. It is also the cause of waste of medical resources and money on unnecessary services which might have a negative psychological impact on the patient. Based on a study carried out by Johns Hopkins Medical School, every year approximately 800,000 people in the US suffer serious harm because of misdiagnosis, among which 371,000 die and 424,000 sustain permanent disabilities. About $750 billion are wasted annually on unnecessary medical services and inefficiencies. Throughout this project, I investigated how we can use artificial intelligence to create an intelligent system that provides diagnosis based on the symptoms of patients. The dataset I used for my project is based on the discharge summaries of patients at New York Presbyterian Hospital. It contains 149 rows, which correspond to the different diseases my project takes into consideration, as well as 404 distinct symptoms. Each disease is represented by an asymmetric binary vector. The functionality of my project is based on the Jacquard similarity algorithm, which can quickly compare asymmetric binary vectors using this formula and provide the user with the percentage of similarity between the vectors. In this way, we can easily sort the percentages and determine the most similar disease. I utilized HTML and CSS to design and create the main and the result pages that constitute the user interface. I also used JavaScript to create a functional mega menu and Python to code the Jacquard similarity algorithm that determines the most probable diseases a patient might suffer from. Welcome to AI Medical Diagnosis, a system that is not created to replace doctors, but instead to help them be more efficient by providing them with possible diseases a patient might have. This is the dataset I used for my project. It consists of 149 rows that represent different diseases and 404 columns that correspond to distinct symptoms. Each row contains an asymmetric binary vector which is used to distinguish the diseases. This is the Python code for the Jacquard similarity algorithm, which calculates the similarity of two vectors using the Jacquard score function, while simultaneously sorting the percentages that are produced. Here, we can see the JavaScript code which is related to the functionality of the options of the mega menu. More specifically, it creates the asymmetric binary vector that contains the symptoms of the patient and then triggers the download of the CSV file. This is the website that doctors can use to get help when making a diagnosis. By hovering over the symptom header, the user enables the mega menu where all the symptoms are displayed. Then, the doctor can select the symptoms of their patient by clicking on the boxes. After he is done selecting the symptoms, he can press the Submit button. This triggers a CSV file which contains the symptoms given by the user to download. This file is then processed by the Python script and the results are displayed in the result page. So, as it seems, this patient is most likely suffering from bronchitis. This project leads me to certain conclusions. First, the algorithm can perceive our world through the input that is provided by doctors. Second, diseases are represented and stored in CSV files as asymmetric binary vectors. Third, the algorithm makes the diagnosis based on datasets from hospitals. The more datasets we use, the more accurate the system is. Fourth, the interaction with the system is achieved through the HTML web page and the mega menu. And finally, the algorithm can produce diagnosis faster and more accurately, thus facilitating the job of doctors, reducing significantly the number of deaths and permanent disabilities because of a misdiagnosis, and in addition, it can contribute to the limitation of wasted resources and help global healthcare evolve. Thank you for your attention.